Hi, everyone. So I'm really happy to be here today to talk about a project that I've been involved in for over a year now. So thanks to Patrick and Brad for inviting me here. My name is Dore. I'm, like a lot of you, a front-end application developer. I started out my career on the server side in .NET and PHP for my sins. And for the past 5 or 6 years now, I've been focusing a lot more on UI development. With how capable browsers have become over the past few years and the evolution of great frameworks like Angular, my passion is really in combining good engineering practice with great design and experience. So over the years, I've worked on projects like Four Seasons, Hotels and Resorts. And my first real foray into responsive design was a marketing content hub for Google called Think Insights. So I'm a developer at Work & Co. We're a digital design and development company. Work & Co. was founded on this philosophy of leaner teams and closer collaboration between disciplines and a more agile workflow in creating these digital products. I'm based in Brooklyn, but we also have operations in San Francisco, Rio, and this beautiful city of Paris. But enough about that. So what I really want to talk to you about today is the responsive redesign of VirginAmerica.com and how AngularJS was used to realize both the technical and creative challenges. So I guess to start, how many of you know about Virgin America or have flown with them? Okay, so not many. So for those who do, or those who don't, they're a US airline based out of San Francisco, and they fly to about 20 destinations within the US. US domestic airlines are generally not good, and Virgin America is not like flying with those other airlines. As you can see here, their aircraft have this crazy mood lighting. Every seat has like in-flight entertainment and power sockets, onboard Wi-Fi on every aircraft. That really boring safety announcement that you get on airlines, they turn that into a music video. And if you go onto YouTube, I think this video has about 10 million views now. It's sort of insane. You should check that out. The reason I'm telling you all this is because this is an airline that wants to do things differently. But the truth is their old website didn't reflect that. So let's go back in time a little bit. This is a site that they had for several years before the redesign. It's kind of busy. There's a lot going on. But I want to draw your attention to this link here. When you expand this link, it reveals a component that allows the user to select where they're traveling from, where they're going to, their dates, the number of travelers, how they want to pay, if they have a promo code. People are coming to the site to book tickets, and the mechanism by which to do that is hidden in a drop-down. Similar to a lot of other airline sites, this homepage served many masters. It was a mix of utility-focused sections, corporate information, news, even pilot news is on this page. They also had a separate mobile site, and for the business, it had become inefficient to maintain 2 code bases. And it just looked a lot like every other airline site out there. When you look at these examples, there's really no way of telling one apart from another. It doesn't tell you who the company is. It doesn't tell you what their values are. And for Virgin, this is a real shame because, as you saw, their in-flight experience is completely unique. So the way we see it, an airline site is a utility. People want to perform a task and go on with their day. It doesn't mean it has to be boring, but it should remove obstacles. So we worked with Virgin to establish a small number of goals for the project. The first one was to improve their conversion rate. More than half of Virgin's revenue comes through the website. They wanted to deliver a great responsive experience, a consistent experience across all devices. Whereas a few years ago, you had to convince clients of the merits of responsive design. Now clients are coming to us asking for that as a requirement, and that's kind of refreshing. And they wanted an online presence that better represented their brand. So we focused our design development sprints around creating the best booking experience on the web. And part of that was deprioritizing features like upsells and promotions. It really was this brute force approach. Like we designed, refined, prototyped, iterated, and tested only around those core goals. So throughout the project, our team spent a lot of time in San Francisco, and we worked at the Virgin America offices. We sat next to the client, oftentimes in this windowless conference room. We prototyped from day one, and we iterated frequently to explore ideas and incorporate feedback. This rapid prototyping forced us to be agile with our decision-making. It also prevented us from being precious about our ideas. As our partner for design put it, there wasn't this design phase and development phase. It really was designers and developers working together. Like, if it didn't work, we'd just go back and try something else as a team. So the prototype became the single source of truth, the Bible. It wasn't meeting notes or sketches or PSDs. It became a reference point for everyone involved, a shared vision of what the product should be. We tested a ton of concepts over several months with almost 50 users. And during those testing sessions, developers were on site and we updated the prototype in real time. So feedback from one user was incorporated, deployed, and tested with another user an hour later. And we really had no idea what the response was going to be to some of these ideas. We'd taken this component that was hidden in a dropdown previously, and we expanded the idea to a full width, like single view series of components. It was a radical change, and there was a big chance that it was going to fail. So we were very excited that most people loved it. They were able to accomplish their task much faster and more straightforward than before. But not everyone. One guy hated it. He still achieved what he wanted to, but he didn't like the design. He wanted more images. He didn't like how it scrolled. But the truth is, you can't please everyone. When you please everyone, it means playing it safe. And when you play it safe, you end up back here again. We knew the idea was radical, but the feedback that we got from user testing gave us a lot of confidence to go ahead and build the app. And for developers, it was great to be part of that process, to see the product that you're building being used. It gives you a much better understanding of where to dedicate your energy to yield the most value. So in the US this year, for the first time, more people are accessing the web via their phones and tablets than through their PCs. And a lot of times on projects, there's a discussion that takes place about mobile-first or desktop-first design. On this project, it didn't happen. This aim of a consistent design and experience across all the breakpoints led us to adopting what we called an everything-first approach. Interaction patterns and UI elements were designed to act and work identically across most parts of the app and at every breakpoint, whether it's picking a seat or filling out traveler info or choosing an avatar. It minimized the amount of breakpoint-specific markup and styles that we created, and despite the fact the technical implementation was mobile first, there were actually very few differences for each component between the smallest and largest breakpoints. Okay, so let's get on to what I'm actually here to talk about. When I was thinking about this session, I really wanted to focus on the major decisions that we made around responsive and how Angular featured into that. I think the architecture is probably a good place to start. So why Angular? Which is a great question for this conference. We knew from the beginning it was going to be responsive, and from working with the technical team at Virgin, they were keen to create a stateless API. There was a clear drive towards the separation of concerns to increase performance and improve stability. And through concepting and user testing, a single-page application had emerged as a solution best suited to meeting not only the technical requirements, but the creative goals as well. Let me say that now. We're not experts in Angular by any means. I'm sure the code samples that I show later will be evidence of that. We had a bit of experience in the team, but for the most part, most of our developers were coming onto the project having never used it before. We did a comparison of MVC frameworks, but I don't want to bore you with talking about data binding or dependency injection or boilerplate. I think many of you have been through that exercise yourselves. For us, it really came down to two things. It was opinionated where it mattered. It provided this framework for developers to join the project and understand the conventions. So within a day, we had new developers coming on and contributing to a quickly growing code base. But it was also flexible where it mattered. We knew from the user testing and the concepting phase that Angular wasn't going to limit the creative vision of the project. It would actually empower it. So this is the application structure that we started out with. Much of it you'll recognize from your own Angular apps, but we broke our services into 3 categories. Because we were dealing with an API that had about 50 endpoints, we had a service dedicated to just handling API requests, responses, error handling, using the HTTP interceptor to actually trap errors and message them to the user. We had one for functional services, as I call them. So services dedicated to one key flow within the application, be it booking or check-in, change, cancel. And then utility services, which were shared services across multiple methods, controllers, directives, and views for sharing data or methods. And I'll go into a few examples of that later. So underneath that, we use Node, NPM, and Grunt not only as our development environment, but also as our build system. For style, Sass was our choice of preprocessor, and we use Compass for mix-ins and patterns. And then we also used a great library called Suzy. I'm not sure how many of you have used it or heard of it, but it was used to create a multi-breakpoint grid system that allow the developers to apply that grid system across the UI. And then finally, we have our, if it updates, there we go. We have our REST API. We had a Java-based CMS, and there was also an API into that for content managed stuff. And then Jenkins was our continuous integration server. It also pushed our deployments to AWS. So this is a very high-level view of the application structure. Each of the major flows had its own directory, which included an Angular module, and then obviously a combination of controllers, directives, services, and templates. Any cross-flow functionality or templates lived in the common folder. And we used require.js to resolve all these dependencies during development. The end result was one core Angular module with each flow application as a dependency. And to prevent naming collisions, we namespaced each application with their own dependencies. You can see it here. So since we're talking about architecture, and this isn't strictly Angular, but I want to talk about the UI framework, because we really wanted to create a UI framework that was as modular and as extensible as Angular was going to provide at the application level. So not only how we structured our files, but conventions around class names, and how we structured our markup to encourage maximum reusability. We followed the BEM methodology. How many of you have followed BEM in the past? Okay. So for those who haven't, it stands for Block Element Modifier. It's a declarative system for CSS classes to provide greater meaning to the developers on your project. The format that we followed was honed by Nicholas Gallagher and described very eloquently by Harry Roberts in his blog post here. This is how I found about it. So this is a version of the markup that we use to render the main navigation on the tablet breakpoint of the site. Sorry, it's a bit small. So to give you some context, a block represents a higher level component, like a building block of the application. An element is a descendant of a block that performs a certain function. It only makes sense within the context of the block. And a modifier is a property of a block or element that modifies its look or behavior. So the result of this was a set of components that worked very well independently, but played well as part of larger systems. We had developers working in multiple countries and time zones, and it allowed them to share these components really easily and reduce repetition. But the reason I'm telling you this is it also changed the way that our designers worked. Rather than handing over templates or PSDs, which I've had in the past, and I'm sure you do too, they approached their own work with this component-based mindset. So it made the workflow between two disciplines much more seamless. So we combined this approach with another methodology from Jonathan Snook called SMAX, which stands for Scalable and Modular Architecture for CSS. And it's more of a style guide than a rigid framework. It recommends how to organize your CSS for large applications. So by using Sass, we use partials to break down our styles into base styles, variables, grids, modules, and themes that we then imported into the main style sheet. So SMAX was great for defining the structure at the the file level. And BEM created this unified declarative language for CSS that really encouraged standardization and component reuse. One of the first questions when you work with designers is, how does a responsive grid work? Which I think is pretty fair. It's actually hard to visualize how breakpoints are going to work in practice. So we prototyped it. We used the SUSE library to scaffold the responsive grid system, defining column widths, gutters, and margins, and then we explored the boundary of each breakpoint. We set up a demo grid very similar to this using simple block elements, and then we used tools like Ghost Lab and Browser Stack to get a feeling for how it was going to work in practice. So the end result of that was a 6-column grid for the small breakpoint and a 12-column grid for medium and large breakpoints. So now we have this responsive framework, one for designers to use in their PSDs and one for developers to use, which were these series of mix-ins they could implement the grid system across the UI. So before I talked about maximum reusability across breakpoints, but sometimes it makes for a better experience to optimize the UI based on viewport size or input type, and Angular made this incredibly easy. Actually, sometimes too easy. The best example of this on our app is probably one of the most overlooked on any site, which is the footer. So it's comprised of 25 links, and we stored the links in a constant that we then injected into the footer directive. The benefit of that separation was it allowed us to render breakpoint-specific markup, including different directives, with a single source of data. So on the largest breakpoint, the links fit neatly into this 12-column grid. On the medium breakpoint, we resort the data and re-render the markup into 4 columns. But this is where it gets a bit more interesting for mobile. So having 25 links on a small viewport actually looks kind of messy. And if they're small, they're also difficult to hit. So we resort the data once more, and we reprioritize the top 10 links, and we show them here. But underneath, now we have a drop-down. When that drop-down is selected, we actually delegate the responsibility of rendering the rest of the links to a modal provider, which is here. So in this example, we actually create a new instance of a modal and a new scope. Because that scope is a child of the footer directive scope, it inherits the links that have already been attached to the footer directive scope. And so what that allows us to do is render this modal, which takes over the screen as a new layer on top of the application. It uses the same data as the other breakpoints, but now allows us to apply things like inertia scrolling and a much larger hit area for each link. We came to see Angular's capability of handling data and manipulating the DOM as powerful methods of fine-tuning the experience. In fact, it's really easy to abuse, as we found out. So we tried to be smart about where it offered real value. I think the main navigation is a great example. The ability to select fares, choosing a particular flight, or viewing your travel summary. It was all about what was best for the particular context. So a few weeks into the project, the UI was coming together, and we'd already built out many of these global components, and we're working on components for the booking flow. But it started to dawn on us how much repetition had crept in to our controllers and directives for observing the state of the window. We were adding event listeners for scrolling and resize events and detecting the current breakpoint in a lot of different places. It's a need that we obviously had quite consistently. So there was this obvious need for centralizing not only listening for window events, but how we set state on components outside of the viewport. So the body, the main navigation, the footer, these global elements. We came up with a Windows service, and in tandem with a window directive attached to the body, this really served two goals. It centralized and aggregated the event listeners on the window for scroll events and resize events. And using a pub submodel, controllers and directives could subscribe and unsubscribe from both window-based events and states on the Chrome of the application. So things like the current breakpoint, the visibility or positioning of navigation bars, even the theme of the site. So our first attempt on this, we set values on the Windows service, and we used watches on the window directive to conditionally add and remove classes on the body using ng class. And it worked, but had two really crazy drawbacks. Well, first, we were updating the scope values every time the user scrolled or resized, and we were firing watches like thousands of times on the page. The performance was really, really bad. And since we were applying classes to the body of our ng class, we were also using the digest cycle. And so there was a noticeable delay when you're scrolling up and down to set these bars as fixed or relative position. And it caused the UI to stutter in contrast to the user's input. So to get around that, which most people probably wouldn't recommend, but we actually circumvented Angular's digest cycle. So instead, the window director subscribes to events from the Windows service, and instead of using ng class, we used JQ Lite to add and remove classes to the body directly. This solution eliminated a lot of the performance jank that we were seeing and made the UI feel much more reactive. And responsive components didn't stop at the website. That philosophy also inspired this printable boarding pass that you could fold up and put in your back pocket. Again, it was whatever was best for the context. This context just happened to be offline. So this is how I feel when I fill out forms. I think everyone would agree that forms are really painful, and people just don't want to fill them out. We knew that. So we thought long and hard about how to make this inevitable process as frictionless as possible. So this is what we did. As the user inputs their data, we perform real-time validation on the fields, not only client-side, but where needed, validation at the API level as well. It not only serves to help correct the user's issues as they're stepping through the process, these feedback labels are an opportunity to incorporate Virgin's voice into the process. So as the user gets closer to completing the form with only one field left, the submit button becomes a guidepost. The idea is that it becomes really difficult to make a mistake, and when you do, you know about it immediately. There are about 30 forms in the application now, so it was really important to create a system that was easy to create these forms and be maintainable moving forward. So we came up with a series of directives. This is a very simple example, but easier to explain. The form handler directive serves multiple purposes. Each input field added to the form registers itself with the handler. When values are input, the form handler aggregates all the data into a single model. The handler is responsible for validation. It not only validates and informs the individual input as it's to its own state, it allowed us to create more complex relationships between groups of form elements when necessary. So the attributes of the form handler were used to configure data and messaging and callbacks, and some of these were applying pre-existing data, defining a model that would store each of the data on the input directive. Sorry, let me go back. Defining callbacks when the form is submitted and all the validation rules are met, and then defining default and error labels for the submit button at the bottom. We were dealing with so much data running through this application. As I mentioned before, we had 50 endpoints from the API, and it became really unwieldy to store and manipulate this data, to format it to be displayed within a view, but then reformat to be utilized with the REST API. I think we made a common mistake in that we made the coupling between the UI and the API so tight that every time the API changed, our UI broke. But we learned quickly on that one. So to combat that, we created these data models that made it really easy to define a schema, create mappings, and methods to serialize and deserialize data from different contexts. So as the API evolved during the course of the project, we just updated our serialization methods, and there was no longer this dependency at the UI level that we had to address. And since the structure of the data from all the forms was consistent, it made it really easy to write deserializers to take that data and extend the model so it could be used in other parts of the application. I think of all the lessons I learned throughout this project, this introduction of intermediary data models proved the most valuable. So the result of this was a series of components that could be combined to create forms, a simple interface in the form handler that made it really easy to write custom input directives, and a standard approach to injecting and extracting form data. But all that was really this opportunity to try and make the process less frustrating for the user. And the feedback so far has been really positive. this morning, when I was looking at the features for 1.3, I realized that most of what we did is actually coming in that. So I wish it had been here like 8 months ago, but whatever. So before I started this project, I saw a talk from my idol, Paul Irish, where he said that on average, over 60% of page weight is contributed to images. So average page weight for the top 100,000 sites is now up to almost 1.9 megabytes, up from 1.2 just 2 years ago. We didn't have a lot of images on the site, and I think part of that lent itself to the goals of the site, but it had this obvious side benefit of keeping the page weight down. There's still work we could do to make it better, though. So for icons, we used Grunticon to manage our SVG icons and background images, and that reduced the number of HTTP requests we were making and made our assets resolution independent. Where images were really necessary, we really wanted to find a way to optimize for the viewport. So we created this image directive and service that leveraged an image resize API provided by Akamai. So for each image in the application, we defined a source image, and that was uploaded to the CDN. Based on the design, we determined the largest applicable breakpoint, a width for each breakpoint, and that was included as attributes on the directive. The first time a new size is requested, it's created and cached on the CDN. So all these responsive image directives register themselves with an image service that we created, and that really served two functions. The first was subscribing to changes in the breakpoint, and the second was when a change occurs, a source value for the image is updated. We also use Modernizer to determine whether the image is on a high DPI display. And when that's the case, we multiply the size values. So the quality is then not only determined by the size of the viewport, but also variable pixel densities. It's such a simple implementation, but for us, provided so much value. When we launched VirginAmerica.com, there were about 35,000 lines of JavaScript in this project. And even with the entire application logic minified into one file, the initial page load was only around 750 kilobytes, in large parts to techniques like this. Yeah, this was a saying that went around the team a lot. So one of the first times I heard about Angular, I saw a video of Mishko talking at an MTV Tech meetup, and an audience member asked him this question about what does he do when he has tables with hundreds of rows of data? And Mishko's answer, which was a good one, was that you shouldn't do that. That there's surely a better way to represent that amount of data. It was really great advice, which we completely ignored. This single-page flow worked really well to guide the user through the flow, but the result was single views with hundreds or thousands of bindings, and the performance implications were significant. So after some research, we made heavy use of Pasquale Vazana's bind once directive. It reduced the number of watches we had in the view by removing those watches after the bind once directive was evaluated. We forked it to meet our specific needs, including the ability to reevaluate those bind once directives using root scope broadcasting. But now, as part of Angular 1.3, this is coming in. I think it's for us, is a huge deal. Because on our heaviest data-driven components, this increased performance by orders of magnitude. About 2 weeks before we launched, during testing, the app crashed some of our mobile devices and tablets. And we took a deeper dive into the Chrome DevTools, and using the memory profiler, we discovered several memory leaks, spikes, and detached DOM nodes that weren't being cleaned up during garbage collection. It turned out that we were exceeding our per-tab memory allocation on mobile browsers, which forced the application to quit. This is our amazing engineer, Igor, in the middle of that. It was this really painstaking process of profiling, isolating, and refactoring to reduce our memory footprint. Our job here still isn't done, but over several stages, we've been able to reduce that by about 150%. And there's a lot of improvement that we can make in regards to accessibility. Like, we know it's not where it should be right now, and we're planning for significant improvements on this front in the future. As part of our efforts to update the site to 1.3, we're already looking at incorporating the NGAria module. And of course, I'm looking forward to Marcy's session tomorrow on accessibility in AngularJS. So the real moment of truth was putting it out to the users. And like I said, because it was such a radical change, it was launched as a closed beta and then an open beta 1 week later. We received some great feedback from members of our own industry, including the father of responsive design, Ethan Marcotte. And we took a lot of the feedback that we got via social channels to heart, using the beta as an opportunity to incorporate requests. So one of those was the ability to search for a lowest fare within a 7-day window. And by the time the site launched, we actually added a lot of additional polish. Even after we launched, that feedback loop continues. And we recently introduced a 30-day fare calendar as well. So we received some nice press, but at the end of the day, none of that matters. The only thing that matters is that the site works for Virgin and for its customers. For the company, they now have a site that speaks to their values and their brand, a consistent experience across all devices, and a single code base to maintain. And though I can't share numbers, so far we're seeing really positive results. It would be remiss of me not to give a shout out to Virgin and my team at Work & Co. Who contributed to the project. I'm lucky enough to be up here to speak about it, but without them, it wouldn't have been possible. They're an insanely talented bunch. And without Angular, it certainly wouldn't have been as fun or as productive. As we've seen today in 1.3, a lot of the most challenging parts of executing this app are about to become much easier when it comes to memory issues, forms, messaging, and single binding. We owe, as a company, a lot to the Angular community, all of you, in getting us to this point, and we're excited to contribute to that community in the future. Thank you very much.